Hi and welcome to MSc. In this video we're going to be looking at balancing chemical reactions, specifically some additional examples. If you haven't checked out my first video on balancing chemical reactions, go check that one out and come on back here after. These ones are a little bit different. They're not necessarily a whole lot more difficult, but they offer some extra wrinkles. So go back and check out that first video to begin with. As you remember from that video, my technique as you're learning is to set up a chart. Once you're experts with this, you'll find shortcuts that work for you, and you might be able to do some of these by inspection as well. The chart I always list out just in the order that I see the elements. So I start with calcium here with the calcium chloride, chlorine's next, and then we're into the sodium phosphate. Now, when I come across polyatomic ions, I often have the option of treating them as a single entity in my chart. So rather than breaking this into phosphorus and oxygen, I can treat it as a PO4 group. Now, I'm allowed to do that when I see phosphate on both sides, and it's even better when I don't see any other phosphorus or oxygen anywhere else. I know I'm not forming this and breaking this apart. So I have one phosphate here and two on this side, so that's not balanced, so I need to balance it. So I'll work through this example where I'm going to treat the phosphate as a single entity here that's not being broken apart or formed in this process. If you're ever unsure, can I do it or not for this equation, I'm not sure, break it apart into the parts, list 1 phosphorus and 4 oxygen, and then you'll always be fine. This can just offer a bit of a shortcut. In the previous video, I had phosphorus being formed in a reaction, so I couldn't treat it as one entity. Then what I do is I repeat the same order on the other side so that I can keep things lined up and everything in order. And then I put a tally down. So I put 1 calcium here, and I have 2 chlorine, right? 1 and 2. I have 3 sodiums, and of the phosphate groups here, because there's no brackets, I have 1. On this side, you'll notice I have 3 calcium, I have just 1 chlorine, I have 1 sodium, and here, because of the 2, I actually have 2 of the phosphates. You want to make sure that your tracking number here and your subscripts don't get confusing. Be careful with that. Then we start to balance. So I need a number in front of the calcium that when multiplied by the 1 is going to give me 3. So I'll put a 3 there, and I'll update my chart. So this is 2 times 3 is 6. That changes the chlorine to 6. Okay, so that didn't mess up balancing, but it did change what I was trying to do. I usually just work through in order. Again, as I mentioned in the last video, the exception is if I see something show up more than other items. In this case, everything shows up twice. So we're good just to work down the chart. So chlorine here, I need a number out front. Multiply by 1, it will be 6. So that's easy enough. That changes my sodium to a 6 as well. And then I look over at the sodium. I need a number out front. That'll be a 2. 2 times 3 is 6. And that means I also have 2 of the phosphate groups. So I'll update that, and that fixes my phosphate problem right there. So this one wasn't really all that much more challenging. It just had the option of treating the phosphate ions as their own entity. Again, always perform a check if you can. So 3 calciums, 3 calciums. 6, because of the 2 times 3 chlorine, 6 chlorine. 2 times 3 is 6 sodium. 6 sodium. This is 2 phosphates and 2 phosphates. So this is balanced. One more example here for us. And this is where we have iron sulfide. It looks like it's an iron 2 sulfide. You can try working through that and using the zero-sum rule to calculate that for yourself. But we have iron, and we have sulfur, and we have oxygen. And those are my only elements in this reaction. Notice oxygen shows up 3 times. I'm going to do it last. It's last in my chart anyways. Iron, I have 1. Sulfur, I have 1. Oxygen, I have 2. Iron, I have 2. Sulfur, I have 1. And oxygen, be careful, it's 3 plus 2, which is 5. So with less elements, this might seem like it's going to be a little bit easier, which is great. We're going to try the iron first, so I'll put a 2 in front. 2 times 1 is 2. And that's also going to update my sulfur. So that messed up my sulfurs because they were 1 and 1 and now it's 2 and 1. So now I need to go over here and put a 2 in front here so that it's 2 sulfur. Of course, that changes my oxygen as well, makes it 4 plus 3, which is 7. Okay, so now I'm trying to figure out the oxygen piece. And here's the trick. Obviously, I need to put a number here because it's the smaller total. But there's no whole number I can put here that when I multiply by 2 is going to give me 7. And so there's a couple of ways to try to puzzle through how to solve this piece. One of them is you could decide, hey, I'm going to put a placeholder of a fraction in here. What fraction would I put in that would make this true? Well, with some fraction work, you'd say that 7/2 would work, because 7/2 times 2, the 2's would cancel, you'd get 7, which is what I want. There are some cases later in chemistry where you will have some fractional coefficients. Perhaps I wanted this to have a coefficient of 1 for some other stuff we're doing with these ratios later on. But for right now, we probably don't want to leave this as a fraction. And so we want to get rid of this fraction. Well, how do I get rid of this fraction? Well, I can multiply by 2. We've already established that. And I would actually find if I multiplied them all my coefficients by 2, then I'll get the appropriate answer. And you can check through that after. The other way to try to approach this is to look at what's causing the odd number here. Well, the odd number here is being driven by this 3. This is even number here. This is the odd that's making this odd. That means I don't have a whole number that can multiply here. So another option, rather than doing the 7/2 and just multiplying everything by 2, which I think is probably the easier approach, is to look at getting rid of this odd piece. So again, I can't ever change this, but if I multiply by 2 out front, then it will get rid of the odd, right? Doubling something always makes it even. So this will mean I have 6 plus another 4 is 10. So I could try that approach where now I have 10 oxygen. Okay, but I also now have 4 of these. So what I have to do now is go back and update my chart. I don't want a 2 there after all. Now I want a different number there. I want a 4. Okay, and the 4 here will also change this to a 4. So it turns out I don't want a 2 there at all, do I? I want to double it to make it a 4. And that's also going to change my oxygen. It's not going to mess up my even piece, but it's going to mess up the 10. This is now 8 plus an additional 6 is 14. And now what number? It's the 7 from the 7/2. Remember. So you'll run into situations like this where you don't have a whole number option. You can either put a fraction and then double everything, getting rid of the fraction, or you can look at what's driving that odd number and double that species, making it even, and then work backwards through things, and things will work out for you, right? We now have 14 down here. So now you can do that check. 4 irons, 2 times 2 is 4 irons. 4 sulfurs, 4 sulfurs. I have 14 oxygen, and here I have 6 plus an additional 8, which is 14 oxygens, and this is balanced. You'll see this situation with this odd number where you might have to do some trickery happen with some combustions of alkanes. So complete combustion where you react with oxygen and produce carbon dioxide and water, you'll see this type of thing occur in those as well. I hope this run through of a couple extra examples of balancing chemical equations has been helpful. If it has, please consider liking the video and subscribing to the station. And as always, thank you very much for listening and watching.